So let's look at the following example that will deal with the concept of electrostatic potential energy. We want to calculate the quantity of energy, the quantity of work that is required to disassemble a hydrogen atom. Assume that the initial distance between the proton in the nucleus and the electron is 0.53 times 10 to the negative 10 meters. So in this example, we're going to neglect kinetic energy. We're going to neglect the fact that our electron is actually orbiting our proton. So we're going to assume these two electric charges, our proton and the electron, are stationary point charges. Now, initially, before any work is done on our system of two charges, we essentially have a distance given by R1 between our two electric charges. So this is our electron and this is our proton, and the distance R1 is given to be 0.53 times 10 to negative 10 meters. Now, after we actually separate our electric charges, our distance R2 is given by infinity. And notice we define at the point of infinity our electrostatic potential between our two electric charges to be given by 0. So, to separate our two electric charges, we essentially have to apply a force. We have to do work on our proton, on our electron, to actually move that electron away, because initially these two charges are opposite in sign, and so that basically means our force will be an attractive force. Now, let's begin by calculating how much electrostatic potential energy exists in this situation. So, electrostatic potential energy given by U is equal to the product of the charge on the electron multiplied by the voltage difference between these 2 points. So QE multiplied by the voltage is equal to QE multiplied by the charge on our proton QP divided by 4 pi epsilon naught multiplied by R1, where R1 is once again this distance separating our two stationary electric charges. Now, we plug in our quantities. We know the quantity of electric charge on the proton and electron is exactly the same, but they're opposite in signs. So the electron has negative 1.6 times 10 to negative 19 coulombs of charge, and the proton has a positive 1.6 times 10 to negative 19 coulombs of charge. Now, we divide that product by 4 pi multiplied by epsilon naught, the permittivity of free space constant, which is 8.85 times 10 to negative 12 coulombs squared, divided by newtons multiplied by meters squared, and we multiply that by our distance, given to be 0.53 times 10 to the negative 10 meters. And we get a quantity of negative 4.34 times 10 to the negative 18 joules. The negative simply comes from the fact that this is an attractive force and we have a negative charge and a positive charge, so our negative essentially comes from this negative sign. Now, we know the work done is equal to the negative of our electrostatic potential energy. So the work that is required to be done on our electron to move it an infinite distance away is negative of this quantity. So negative multiplied by negative gives us a positive. So the quantity of work that must be done on the electron to separate it from our proton is positive 4.34 times 10 to the negative 18 joules. And to convert from joules into electron volts, we divide this quantity by 1.6 times 10 to the negative 19 coulombs, and we get positive 27.1 electron volts. So once again, it's positive because our electric potential energy is negative, because this is a negative and a positive charge.